Number 13 says a feather was dropped from the top of a building, a 100-meter building actually. It fell at a constant rate of 0.5 meters per second. Represent this function with a table, graph, and algebraic generalization. Determine the slope, y-intercept, x-intercept, which is also called the zero, of the function, and explain their meaning in the problem situation. Now, the table and graph, I'm actually going to let you do because you know how to type that in the calculator. Pull that up and check your work. I'm going to skip down to where it says algebraic expression, slope in context, y-intercept in context, and change this to say x-intercept in context. So, algebraic expression. Well, it's telling us in the problem that we're falling at a constant rate. So I know that they're telling me right there my slope, my rate of change. Since we're falling, it's going to be negative, and we're falling at a rate of 0.5 meters per second. So my slope is negative 0.5. My y-intercept, which is where the feather is actually starting, is going to be at 100 because that's the height where the feather started. So my algebraic expression is y equals negative 0.5x plus 100. Now, we just talked about slope. What does the actual slope mean in the context? Well, it means that we're falling at a rate of 0.5 meters per second. Same thing for our y-intercept, just like we just said in the problem. Our y-intercept is where we're starting, and our starting value is at 100, so our y-intercept is telling us that we're starting at a height of 100 meters. And you can put off the ground, but we kind of already know it's off the ground. So now, our x-intercept. Our x-intercept happens when y is equal to 0. So if you looked at your graph on your calculator, you probably didn't see your x-intercept. So that means you have to zoom all the way out until you can see it. Now in this problem, you could also pull up your table and look up your x-intercept, and you're going to have to scroll all the way down, or you can just solve it. Plug in 0 for y and see what your actual x-intercept is. Once you solve it, you'll come out to see that your x-intercept happens at 200. So what does this mean? This means that it's going to take 200 seconds before the feather hits the ground. Just think about your graph. Think about your graph. Think about your table. Your x values represent seconds. So when that line crosses that x-axis, that shows you how many seconds before it hits the ground.